Hello viewers, my name is Mr. Adebanjo. I want to welcome you to my channel, and then in this video we are going to be discussing another topic in mathematics that is very important to both general mathematics students and further mathematics students. So in this video we are going to be talking extensively on sequences and series. We are going to be talking about sequence and series, and under sequence and series, there are a lot of things we are going to be discussing, and some of them are highlighted on this screen right now. The first thing we are going to be talking about is to define this what sequence and series, and we are going to give different examples of sequence and series. We are going to be talking about not all the sequence and series, but two categories of sequence and series, which are arithmetic progression, which is also called linear sequence, and we're going to be talking about geometric progression, which is also called exponential sequence. We're going to discuss the number of terms of arithmetic progression and geometric progression. We are going to talk about the sum of terms in AP and GP, and also we are going to provide solution to examination question, both WAEC and NECO, and we are going to give lots of assignments. So we have a lot to discuss or to rub mind together on a sequence and series. So we are going to explain it as best as we could, and we want you to pay attention to whatsoever details we are going to be passing across to us in understanding sequence and series. But before we get it started, if you are yet to subscribe to this channel, please click on the subscribe button on the channel right now. You can also click the bell, which is the notification button, so that you will be notified whenever we post the video on this channel. You can as well help us to promote the channel by sharing the video, click and comment on the video, and share the video with a student in a school so that you can benefit their life one way or the other. So without wasting much of our time, like I said, we are going to be discussing extensively on sequences and series. So what is sequence and what is series? That's the first thing we want to discuss right now. What is sequence, or what are sequences, and what are series? So we'll first of all talk about sequence, and from there we'll use the idea to understand series, because when we have sequence, we can get series from sequence. So like I said here, sequence is the arrangement of numbers in a specific pattern separated by a comma. So I want you to underline the word specific pattern, then separated by comma. These are keywords in this definition of sequence. That is, when it comes to sequence, we are arranging numbers in a specific pattern. That is, we are not just arranging number anyhow, but there is a pattern to which the numbers are arranged, and each number is separated by a comma. So that's what defines a sequence. Of course, we are students of mathematics. We are very used to numbers. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can see that the number I mentioned now are arranged in a particular pattern: 1 followed by 2, followed by 3, followed by 4, followed by 5. But that is not yet a sequence unless you separate those numbers by comma, then it becomes sequence. And you can see that those numbers that are arranged, they are not just arranged anyhow. I didn't just write 1 and I write 1000 followed by 2, followed by 3000. No, that one does not make any sense, because it's not following a particular pattern. So anytime you are talking about sequence, the number that is arranged must follow a particular pattern. Then each number is separated by comma. Then we are talking about what sequence in that case. Examples are the number we have here. We have 5, 9, 13, 17, 21, and dot dot dot. It means, which means it continues. This number you have here, this is a sequence because it is, you can see that each number is separated by comma, and then there's a pattern to which the number is arranged. This is what we discussed for the year. We are going to explain that. Then look at the second example here: 31, 26, 21, 16, 11. This one is increasing, this one is decreasing. So this is also a sequence because those numbers are arranged in a particular pattern separated by comma. We are going to explain that here also. Look at example number 3. We have 39, 27, 81, 243, comma, and so on. Then these are example of a sequence, and because these numbers in each of the sequence are arranged in a particular pattern, and each number are separated by comma, as you can see clearly on the screen right now. Although we are going to explain how they arrive at this each of the sequence here in this what you have under here. So if I ask you to give me an example of a sequence, you should be able to give me an example of sequence. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on is a sequence. So because the numbers are arranged in a particular pattern. So now, why do we have this here? I just want to understand that these numbers are not just arranged anyhow, but there's a pattern to which these sequences are arranged. So that's why I just want to show you here, so as to validate the definition of specific pattern here. So let's look at the first one. Now, this T1 you have here means first term. Like I explained, let me explain. Look at this sequence you have here. The first number here, the position of this first term here, where it's sitting, is called the first term. This second one is called the second term, third term, fourth term, fifth term, to the last term or end term. So this T1 is gotten. How did they get the T1 here? The first term here is gotten by 5 plus 4 times 0. If this pattern work for the remaining one, that means that's correct. Let's see. 5 times 4, 5 plus 4 times 0. What is 4 times 0? That is 0 plus 5. That will give us 5. How did they get the second term, which is 9? 5 plus 4 times 1. So 4 times 1 will give us 4 plus 5. That gives us 9. That's how they got this 9. How did they get the third term? T3. 5 plus 4 times 2. 4 times 2 give us 8. 8 plus 5 give us 13. You can see. How did they get the fourth term? T4. That should give us a 5 plus 4 times 3. Are we there? 4 times 3 give us 12 plus 5, that give us 17. Then how did they get this in this fifth term? That should be fifth term. That should be 5 plus 4 times. We are looking for the fifth term. That should be this n means term that we are looking for, which is 5 minus 1. That gives us 4. 4 times 4 gives us 16. Then 16 plus 5 will give us 21. If you are looking for the sixth term, that means you have 5 plus 4, then 6 minus 1. 6 is the term we are looking for, which is 6 minus 1 gives us 5. 5 times 4 is 20. 20 plus 5 gives us 25. Then and so on and so forth like that. Then how do we not get the pattern to which this sequence is gotten or derived? If you open this bracket, this 4 times n here will give us 4n. Then 4 times 1 will give us minus 1 minus 4. Then we have 5 plus 4n minus 4. Then you can collect like time. 5 minus 4 give us 1 plus 4n. So it is this pattern they have used to get this sequence you have in here. So if the first term, that is our n is 1. So if I put 1 here, that will be 4 times 1 give us 4 plus 1, that gives us 5. The second term, which is our n, is 2. If I put 2 here, 2 times 4 is 8 plus 1, that gives us 9. If the third time, if I put 3 here, 4 times 3 gives us 12 plus 1, that gives us 13, and so on. So that means this is the pattern they have followed to get this sequence. I'm just trying to establish the fact that sequence must follow a specific pattern. So for this sequence, this is this pattern they have used to generate this sequence. Let's look at the second sequence. The first term, they got it as a 31 minus open bracket 5 times 0 5 times 0 is 0. 31 minus 0 give us 31. Next one, 5 times 1 is 5. Then 31 minus 5 will give us 26. Next one, 5 times 2 give us 10. 31 minus 10 will give us 21. Next term, which is the fourth term, 5 times 3, that will give us 15. 31 minus 15, that will give us 16. Next one is 5 times 4, which is 20. 31 minus 20 will give us 11. Then the next one will be 5 times 5, which is 25. That will be 6 term. 25, 31 minus 25, that should give us 6. 31 minus 25, sorry, that should give us 9. So, and so on like that. Then, if that should be the case, if you have to find the 20th term, how do we get that? They got all this number you're having 0, 1, 2, 3, 4 here by using this number of term here. The first one is still 1, that will be term is 1, that will be 1 minus 1 will give us 0. Second term here is term is 2, n is 2, n minus 1 will give us 1. Sorry, 2 minus 1 will give us 1 other. Third term, n is 3, 3 minus 1 will give us 2. Fourth term, n is 4, 4 minus 1 is give us 3. Fifth term, n is 5, n minus 1 will give us 4. Then 20th term, n is what? 20. 20 minus 1 will give us 19. So 19 times 5, then whatever we got minus 31 will give us 20 term. So therefore, if you want to get the pattern to which they got this sequence, that will be the term you are looking for is equals to 31 minus 5 times the number of times you are looking for minus 1. So if you open the bracket, you have 5 minus 5 times n will give us minus 5n. Minus 5 times minus 1 will give us plus 5. 31 plus 5 will give us 36 minus 5n. So it is this pattern they have used to generate this sequence, which you can also call the nth term, or the last term. So if I put, if my number of terms is 1, I'll put 1 here. That will be 5 times 1 will give us minus 5 here. 31 minus 5 will give us 36 minus 5 will give us 31. If my t is 2, second term, then I have 2 times minus 5 will give us minus 10. 36 minus 10 will give us 26. Then next one is n is 3, minus 5 times 3 gives us minus 15. Then 36 minus 15 will give us 21. And so on and so forth. So they have used this pattern to get this sequence. Don't forget, you are justifying that a sequence must follow a particular pattern for arrangement and separated by what? Comma. Let's look at this last sequence here. We have how did they get that sequence? Our T1 is 3. The first time is 3. Then the second time is 3 raised to power 2, that give us a 9. The third time is 3 raised to power 3, that will give us 27. Then the fourth time is 3 raised to power 4, that will give us 81. Then the next time, which is the fifth time, will be 3 raised to power 5, that will give us 143. Then therefore the pattern they have used to get this sequence is 3 raised to power n, which where n is the number of terms you are looking for. If I'm looking for the 20 term, now that will be 3 raised to power 20, or whatever you give me will be the 20 term. So whatever you are having here is talking about the pattern for the above sequences. How do they get this sequence? That what they have we are showing you here, that a sequence must follow a specific what pattern. Are we there? A sequence must follow a specific pattern separated by comma before you can call it a sequence. You are not just going to arrange a number anyhow and call it sequence. That we are talking about now. You can't just arrange number anyhow you see it and you separate it by comma and call it a sequence. No. The arrangement of the number must have a particular sequence before and separated by comma before you can call it sequence. I hope I'm clear. Alright. Then if you understand what is sequence, what is series? Series is the summation, that is addition of the terms of the sequence. Like in the sequence, we separated these terms by comma. But when it comes to in series, we don't use comma to separate the numbers. We use plus sign to separate the terms, and that means sequence becomes series when the terms are separated by addition sign. Do you understand that now? Instead of using comma in sequence, we use addition sign to separate the terms. Then that means you are talking about series in this case. This is series now, not sequence again. So I can ask you a question: when does a sequence become a series? So instead of using comma in sequence, we use addition sign to represent to separate the terms in series. So technically, you can also regard a series as a sequence, because of course now a series is also is also following a particular pattern in arrangement, but instead of using comma to separate the terms, we use addition sign to separate the terms. So by now you should be able to differentiate between sequence and series. So if that is the case, now for the purpose of this discussion, or for the purpose of this lecture, we are not just going to talk about all the sequence and series that we have. No, that would be too much for the scope of this discussion. We are not going to talk about all the sequences and all the series. No, we are going to focus our discussion on two types of sequence and series, which is arithmetic progression, which is also called linear sequence, and geometric progression, which is also called exponential sequence. So all our discussion in this video, or in this lecture, we base on arithmetic progression as one of the sequence, and the geometric progression as the other sequence we are going to be talking about. So don't forget that arithmetic progression, which is shortened as AP, is also called linear sequence, and the geometric progression, which is called GP, is also called exponential sequence. So when I mention linear sequence, you should know that I'm talking about arithmetic progression, and when I mention exponential sequence, you should know that we are talking about geometric progression. Is that clear? Now let's talk about arithmetic progression, which is also called linear sequence. The question I always ask students is, how do I identify a sequence that belongs to arithmetic progression? If you see your friend, as an example, you should be able to identify your friend. My friend is Khadija, because of the features she possesses. Ah, Khadija is very fair, she's tall, she's dark, and so on. You should be able to identify your friend Khadija. The same thing I always tell my students, that we have we have a lot of sequence and series, but you should be able to identify the sequence that belongs to arithmetic progression, because there are some questions that will come your way that they will not mention whether the sequence belongs to arithmetic progression or it belongs to geometric progression. They will just give you the sequence. It is now left for you to be able to identify whether the sequence belongs to AP or GP. I hope I'm clear. So you must be able to identify the sequence that belongs to GP. You must be able to identify the sequence that belongs to arithmetic progression. Now that we want to talk about arithmetic progression, which is also called the linear sequence. How or what is arithmetic progression? Anytime you have a progression or a sequence, and in between between any two successive terms, there's a common difference in between any two successive terms, that means the sequence belongs to arithmetic progression. I will come again. Arithmetic progression or linear sequence is a sequence which have common difference between any two successive terms. Like I said in earlier slide, that the position of these numbers you are seeing here are called terms. The position where they are sitting are called terms. This is the first term, second term, third term, fourth term, fifth term, and so on, like that, to the last term or nth term. This is the first, second term, third term, fourth term, fifth term, and so on. So how do I identify arithmetic progression or a sequence that belongs to arithmetic progression? if I pick two successive terms, what do I mean by two successive terms? This term minus second term minus the first term. The whatever it give me, and I also do third term minus second term, it give me the same answer. And I do fourth term minus the third term, it give me the same answer. And I do fifth term minus the fourth term, it give me the same answer. That means the progression is arithmetic what? Progression. Don't do first term minus second term, that is wrong. It is second term, excuse me, it is the second term minus the first term, third term minus the second, fourth minus third, fifth minus sixth, seventh minus sixth, and so on like that. So anytime you have a sequence and there is common difference, what mean of difference? Minus. There is a common difference between any two successive terms, that means the sequence belongs to arithmetic progression. What is 2 minus 1? That gives us 1. What is 3 minus 2? That is 1. 4 minus 3? That is 1. 5 minus 4? That is also 1. So you can see that there is a common difference between any two successive terms of this sequence. That means this sequence belongs to arithmetic progression. AP. Even though if you are not told, you should be able to know that it belongs to arithmetic progression. Let's look at the second example. We have 2, 4, 6, 8, 10. Does this belong to arithmetic progression? We can't say. We don't know yet until we confirm or verify. That means it must have a common difference between any two successive terms. Let's see. What is 4 minus 2? That is 2. 6 minus 4? That is 2. 8 minus 6? That is 2. 10 minus 8? That is 2. That means this sequence also belongs to arithmetic progression because it has common difference. Let's look at the third one. We have 5, 10, 15, 20, 25, 30. Does this belong to arithmetic progression? Yes. What is the common difference? 5. 10 minus 5 is 5. 15 minus 10 is 5. 20 minus 15 is 5. 25 minus 20 is 5. 30 minus 25 is 5. So you can see that this also belongs to arithmetic what? Progression, even though you are not told. Let's look at the fourth one. We have 12, 19, 26, 33. Can you tell me the common difference between these terms? Any two successive terms here? I'll give you 2 seconds to figure that out. Excuse me. What is the common difference between any two successive terms for this sequence? Do you know it now? Yes. The common difference is 7. 19 minus 12 is 7. 26 minus 19 is 7. 33 minus 26 is 7 as well. So there's also common difference between two successive terms of this progression. That means it belongs to arithmetic progression. Let's look at this as well. We have minus 3, minus 1, 1, 3, and so on. Does this belong to arithmetic progression? The answer is yes. What is the common difference? Let's figure that out. That is minus 1 minus minus 3. Minus 1 minus minus 3. Minus times minus will give us plus. That means you have minus 1 plus 3. That will give us 2. 1 minus minus 1. That will give us 2. 3 minus 1. That will also give us 2. So that means this also belongs to arithmetic progression. We have 60, we have 53, we have 46, we have 39. Does this belong to arithmetic progression? The answer is yes. Let's figure out what's the common difference between this. What is the common difference for this progression? The answer is minus 7. So we are having 53 minus 60, that will give us minus 7. 46 minus 53, that will give us minus 7. 39 minus 46, that will give us minus 7 as well. So we can see that all this sequence given under this example, they all belong to arithmetic progression because they have common difference in between any two successive terms. You can see that some of the sequences are increasing while some of them are decreasing. So it doesn't matter whether it's increasing or decreasing. Once you can deduce that there is a common difference in between any two successive terms in the sequence given to you, that means the sequence belongs to arithmetic progression. I hope you understand that very clearly. If you do, then your first assignment is to give 4 more examples of arithmetic progression. Like you have here, we gave you 6, so add 4 more, making 10. Arithmetic progression. 4 more examples. So you have 7, 8, 9, 10. Give more 4 more examples for this arithmetic progression. So if you truly understand the arithmetic progression, give 4 more examples. Now, like I said, we have terms in arithmetic progression. Terms. Like I said, look at this sequence we have here right now. Does it belong to arithmetic progression? Ask yourself the question. If it does, then what is the common difference? That will be 4. 9 minus 5 give us 4. 13 minus 9 will give us 4. 17 minus 13 give us 4, and so on. So that means this sequence belongs to arithmetic progression. But we want to discuss terms in arithmetic progression. What is terms? Or what are terms? Terms, like I said before, they are the position of these numbers here. The position they are occupying are called terms, or is called term. This one is the first term, second term, third term, fourth term, fifth term, sixth term, seventh term, to the end term or last term. Look at this sequence as well. This also belongs to arithmetic progression because the common difference there is what? 4. Now, this is the first term, second term, third term, fourth term, and so on to the last term. Let's compare this sequence and this sequence. The difference between this sequence, both of them belongs to arithmetic progression 1, but this one does not have an end. We don't know the end of this one, but this one we know the end of this one. The end term is what? 36. The last term or the end term of this sequence is what? 36. But as far this one is concerned, we don't know the last term. We don't know the end of it. It continues. Like this one and this one, the end of this sequence is what? 36. So you should be able to differentiate between this one and this one. This one does not have a last term. It continues, but this one has a last term, which is 36. Are we there? So, like I said, we are talking about the terms in arithmetic progression. This is the first term. So we use A to represent the first term of arithmetic progression. Small letter A. The first term of our AP is called A. So A is what? The first term of an AP. I can ask you this question. What's the first term of an AP or of an arithmetic progression? It is A. Are we there? Good. So we have been talking about common difference since we use D to represent common difference in arithmetic progression. So whenever you see D, you should know that it represents the common difference for the progression that we are talking about. So I'll come again. We use A to represent the first term, and the common difference between the terms we use D to represent it. So in this case, this sequence now, our D is what equals to what? 4. In this sequence now, our D is also equals to what? 4 as well. So don't forget, D represent common difference. Then the first term here, which is represented by what? A. So that means A is equal to what? 5 here. A is also equal to what? 4 here. Do you understand that now? Then if the first term is A, what is the second term of an AP or of an arithmetic progression? Second term of an AP is A plus D. Let's see that in action. The first term is 5. Then the common difference, we said the common difference of this one is what? 4. 9 minus 5 gives us 4. So if I had 4, which is the common difference to the first term, which is 5, what will it give me? Give me 9. So that means the second term of an AP is A plus D. Let's verify that in this one. The first term, which is A, is 4. What is the common difference? It's also 4. So 4 plus 4 will give us what? 8. Do we understand that now? So the first term of an AP is A. The second term of an AP is A plus D. Do we understand that? The third term of an AP is A plus 2D. A plus 2D. A plus 2D, we can verify that. That will be 2 times 4. That gives us 8. 8 plus 5 gives us 13. So the third term of an AP is A plus 2D. If I ask you what will be the fourth term of an AP, A plus 3D. What will be the fifth term of an AP, A plus 4D. What is the sixth term of an AP, A plus 5D. What is the seventh term of an AP, A plus 6D. What is eighth term of an AP, A plus 7D. What is 10th term of an AP, A plus 9D. What is 20 term of an AP? A plus 19D. What is a 100 term of an AP? That will be A plus 99D. Do we understand what how we got that? Yes. If you don't, how did you get the one all these 2 3 you're having here? Like I said, the first term is A. The way they got is A plus the number of times we are looking for, which is the first, minus 1. 1 minus 1 multiplied by D. 1 minus 1 is 0. Multiplied by D, that will give us 0. 0 plus A will give us A. That's the first term. The second term is A plus, second term we are looking for is 2. That will be 2 minus 1 times D. 2 minus 1 will give us a 1. 1 times D will give us D. That will give us A plus D here. Third term will give us A plus 3 minus 1. That gives us 2 times D. We are looking for fourth term. That will be 4 minus 1. Give us 3D. Then the 10th term will give us 10 minus 1. That gives us 9 times D. And so on. So technically, if I'm looking for the number of term of an AP, I will use the formula A plus open bracket n minus 1 multiplied by D, where n here is talking about the term you are looking for. If I'm looking for 10 term, that will be n will be 10. If I'm looking for 20 term, n will be 20. If I'm looking for 19 term, n will be 19. So like if I'm looking for the 20 terms now, that will be have 20 minus 1, that will give us 19. So 20 term of an AP will be A plus 19D. That's how I got what I said the other time. So if I ask you now, what is the 25th term of an AP? Let me give you 2 seconds to figure that out. What is the 25th term of an AP? 25th term of an AP. Do you know that? That is A plus 24D. Are you right? Are you correct? I hope you said it right. I hope you said the same thing I said. Okay, let me ask you, what is the 50th term of an AP? 50th term of an AP. Have you said the answer? Say it in your mind or write it down before I say my own answer. That would be A plus 49D. 50, that 50. So what is a 28th term of an AP? That should be A plus 27D. What is the first term of an AP? That is A. What is the second term of an AP? A plus D. Third term of an AP? A plus 2D. Fourth term of an AP? A plus 3D. Fifth term of an AP? A plus 4D. Seventh term of an AP? A plus 6D, and so on and so forth. So technically, if I want to find any term in AP, if I'm sure that the sequence is arithmetic progression, and I also find any term in AP, I can use this formula A plus n minus 1 into bracket D to find it, where A is our first term of the sequence, then n is the number of terms we are looking for, then D is the common difference of the sequence. Like this one now, this is 1, 2, 3, 4, 5, 6, 7. We stop at 7. Imagine question asks you to find the 20th term of this sequence. You don't need to continue to add 4 to it to get to 20th term. You can just put 20th term. That will be A plus 19D. Your A will be 5 plus 19 times. What's the common difference? 4. Simplify that. That will give you, when you get to 20th term, it will give you the answer you're going to meet there. Do you understand that? So I can ask you, because there are some questions that will lead to simultaneous equation. You can be given that the 20th term of an AP is 50, or 20th term of an AP is 50. How do we write that? What's 20th term of an AP? That would be A plus 19D equals to what? 50. So there's a question that will lead to simultaneous equation here. So that's why you need to know what is the particular term of an AP. So if I ask you what is the 7th term of an AP, that would be A plus 6D. Can we continue? Yes. Now, if you understand what you have just discussed, let's solve some examples on arithmetic progression. What is the 23rd term of an arithmetic progression? Minus 7, comma, minus 3, comma, 1, comma, and so on. So the question means that when we continue this sequence and we get to 23rd term, what are we going to meet there? That's what they want us to know, to derive. If we continue this sequence and we continue it, and by the time we get to 23rd term, what are we going to see there? That's what they want us to know. So it's very simple. We know the first term. What is the first term? minus 7, and we need to get the common difference. That will be minus 3 minus minus 7, or 1 minus minus 3. So that will give us the common difference, because we are already been told that it is arithmetic what progression. So that means we are not told. That means we need to verify if it is arithmetic progression or not. But you have been told. That means it's arithmetic progression, and you can get the common difference. Like I said that we have to, yeah, like I said here, like I wrote here, we have to find the 23rd term. Let me ask you, what is the 23rd term of an AP? Before I say it, what is the 23rd term of an AP? Do you know it? If you know, you say it in your mind or you write it down. 23rd term of an AP is A plus 22D. A plus 22D. How do we get that? We can get that from the formula of finding number of term, which is A plus n minus 1D. So we are looking for 23rd term. That will be n will be 22. So that means you have A plus 22 minus 1. What's 22 minus 1? That will give, sorry, 23 minus 1. That will give us 22 times D. That will give us A plus 22D. You can see that. So 23rd term of an AP is A plus 22D. Do we understand that? So we need our first term. What's our first term? That is a minus 7. Then we need the common difference D. How do we get that? That would be minus 3 minus minus 7, or 1 minus minus 3. That will give us what you have here, minus our common difference, which is D, equal to minus 3 minus minus 7, and that will give us a minus 3 plus, and that will give us 4. So that means the common difference is 4. So if you put that into this 23rd term of an A of this AP, that means you have a minus 7. Our A is minus 7 plus 22 multiplied by common difference, which is 4. So minus 7 times 22 times 4 is 88. Then minus 7 plus 88 will give us 81. So that means if I continue this sequence and I get to 33rd term, I'm going to see 81 there. That's what it means. Do you understand that? So that means the 23rd term of this AP is 81. If I ask you to find, let's say 50 term of this AP, what will you do? What is the 50 term of this AP? You have 50 minus 1 here. That will give us 49. Multiply by D, that will give us A plus 49D. So here you'll be having A plus 49D. Put the value of your A, put the value of your D. Simplify, you give you the value of the 58th term. Do we understand that? Let's see another example. Find the 48th term of the linear sequence 6, 11, 16, 21. We are looking for what? 48th term. That is, when we continue this sequence and we get to 48th term, what are we going to see there? So we are told that it's a linear sequence, and we know that another name for linear sequence is arithmetic progression. So we know the first term. What's the first term? If I ask you, the first term is what? 6. Our A is 6. Then what's the common difference? If you know it, say it in your mind. The common difference should be what? 5. 11 minus 6 give us 5. Then 16 minus 11 also give us 5. 21 minus 16 also give us 5. Though that means the common difference is 5. And our n is what? 40, because you also find the 40th term. So this is the formula of finding number of term. We are looking number of term, which is A plus n minus 1 multiplied by D. So what is the 40th term of an AP? If you put 40 here, that means you have 40 minus 1 will give us 39. So that means the 40th term of an AP is A plus 39D. Do we understand that? This is 40th term. N is 40th term we are looking for, equals to A plus 39D. So our A is 6 plus 39 multiplied by common difference is 5. So 39 times 5 will give us a 195 plus 6, that give us 101. So if you continue this sequence by adding, common difference is 5, by adding 5, adding half 5, by the time you get to 48th time, you see 201 there. I hope you understand that. Let's see another question. Good. Find the number of terms in the arithmetic progression. Find the number of terms in the arithmetic progression 2 minus 9 minus 20 comma dot dot dash comma minus 141. So look at this. What are you asked to find here? They did not ask you to find a particular term. No, they want us to know how many terms do we have from these two to minus. Sorry, pardon me for that. They want to know how many terms, how many times do we have from 2 to minus 141. The value of our n in this case now, from n from 2 to minus 141. You can see that there are some terms that they have already omitted here, around here, before they got to minus 141. So that means the end of this sequence, or the last term of this sequence, is what? Minus 141. So we can use that to get the value of our n in this sequence. That is how many terms we have in this sequence. So we have the first term, which is our a, is equal to 2, and we can find the common difference. That will be minus 9 minus 2. Minus 9 minus 2, that will give us a minus 11. Or you do minus 20 minus 9. So that will give us a minus 20 plus 9. That will give us minus 11 as well. But what we don't know is our n, which is the number of terms we have to find. That is, they want to know how many terms we have from 2 to minus 20, minus 1, minus 141. Which are, so we are looking for the value of our n. Are we there? So we know that the number of terms in AP is a plus n minus 1 multiplied by d. This nth means the end term. Also, we can also call this one nth term. N means the number of terms we are looking for. We can call this one nth term. Nth term, that is the last term of an AP. So we know the last term here, which is 1 minus 141. So that can replace this nth term. So we have the nth term equals to a plus n into n minus 1 multiplied by d. So this nth term is equals to minus 141. So we can replace this one with this one here, equals to our a is what? 2 plus, we don't know the number of terms we are looking for. So we have n minus 1, close the bracket, into our common difference is what? Minus 11. From there we can open the brackets. There you'll be having 2, then minus 11 times n will give us minus 11n. Minus 11 times minus 1 will give us plus 11. From there we can take the like times. We have 2 plus 11, that will give us 13 minus 11n. Take the like times. So we have 13 will go here. That means you have minus 11n equals to minus 141 minus 13. So minus 141 minus 13 will give us minus 154. So minus can take care of minus at both sides. Then you can divide both sides by by 11 to get the value of our n. So n will be 155 divided by 11, and that gives us 14. So that means we have 14 terms between these two and the minus 141. We have 14 terms there. Do you understand that? So if I'm given the last term of an AP, I can know how many terms we have in that sequence. If I'm not told, if you are not told rather. In this case, we are not told, we have to find it. So since we know the last term, we can use that. You can use this to get the number of terms we have in that sequence. Since we know the last term, which is our nth term here, and we know the first term, and we can find the common difference here. So we can find the value of our what? Our n, which is talking about the number of terms in that sequence. Do we understand that? So there's a difference between this question and this question here. You should know the difference. This one is talking about we should look for the value that will be in the 40th term. That means we know the value of our n here. N is 40. But in this question, we don't know the value of our n, but we know the last term. So we can use that to find the number of term we have between 2 and minus 141, which is our n. Let's see another question. This is a WAEC question, 2006, question number 11b. We are told that the second term, the second, the third, and the fourth terms of an AP are x minus 2, 5, and x plus 2 respectively. Calculate the value of x, or find the value of x. It's quite simple. Very simple. The second term, third term, and the fourth term of an AP is this, and this. So that means this is the second term of the AP, this is the third term of the AP, and this is the fourth term of the AP. So you have to find the value of x. So we know that when it comes to arithmetic progression, since the term they follow one another, this is the second, third, and fourth, they follow each other, isn't it? It's not that we have 1, we have 4, we have 6. No, that one is not. They didn't follow each other. They are not consecutive. But in this case, they are consecutive: second, third, and fourth. So that means if you find the common difference between third and second, and fourth and third, then the common difference between this one and this one should be equal to the common difference between this one and this one, because we know that arithmetic progression has common difference between two successive terms, isn't it? Yes. So the difference between this and this should be equal to the difference between this and this. Common difference is equal to third term minus the second term, should be equal to the difference between the fourth term and minus the third term. That's what you're having here. So which means that 5 minus, which is this is the third term, minus the second term, which is this one, should give us the same answer as this minus this. Is that correct? Let's look at it critically. So 5 minus 5 open brackets s minus 2 should be equal to s plus 2 minus this 5, which is the fourth minus third, should be equal to third minus second. So that's what you're having here. So from there, you can find the value of our x. If you open the bracket, we have 5, open the bracket, minus, will open the bracket here, you have a minus s, then plus 2. Then here you can collect like time, 2 minus 5 will give us minus 3. Then 5 plus 2 will give us 7, minus x equals to s minus 3, collect like times. There you'll be having s comes here, you become plus x, that means you have s plus x, this 3 comes here, you become plus 3. You have 7 plus 3 equals to s plus x. So 10 is equal to 2s. Divide both sides by 2. That means s will be 5. So the value of our x is the 5. Is 5 rather. So some question can ask you to now get the progression for them. What is the progression? So that means you need to put your 5 here. 5 minus 2 will give us 3. So we have 3, 5, 5 plus 2, that gives us 7. So we have 3, 5, 7 as the progression. Do we understand that? But in this case, we are not asked to do that. We are only asked to find the value of x. Let's look at another question. If 8, s, y, z, and 20 are in arithmetical progression, find x, y, and z. 8, s, y, z, and 20 are in arithmetic progression. Find x, y, and z. What can we say about this? Although we have been told that it is arithmetic progression, so no problem about that. We know the first term. What's the first term? Our a is 8, x is the second term, y is the third term, z is the fourth term, and 20 is the what? Fifth term. Do we understand? Which we can also call the last term. 20 is the last term, or we can also call it the fifth term. So since they follow each other like that, so we know the first term. The first term is 8. Then the fifth term. What is the fifth term? The fifth term is what? 20. So, and what's the fifth term of an AP? A plus 4D. What is the fifth term of an AP? It is what? A plus 4D. So A plus 4D is equal to what? 20. This is the first, second, third, fourth, and the fifth. What is the fifth term of an AP? A plus 4D. And what's the value of the fifth term? It is 20. So 20 is equal to A plus 4D. So since we know our first term, which is our 8, we can put that here. So we have 20 equals to 8 plus 4D. You can take the like times by moving this one here. That means you have 4D is equal to 20 minus 8. So 20 minus 8 is 12. We can divide both sides by 4. That means D will be 3. Now that means we know the common difference for this arithmetic progression. So we know the first term 8. We know the common difference 3. So from there we can find the value of our x, and we know that our x is the second term. What's the second term of an AP? I want to ask you a question. What's the second term of an AP? That will be A plus D. So that means our S, which is second term, is equal to A plus D. So our A is 8 and our D is 3. So that means second term will be 11. So S is 11. Our Y is the third term. What's the third term of the AP? Of an AP? A plus 3, A plus 2D. Y is equal to A plus 2D. So we know our A, we know our D, so we can substitute that there. So you will be having 8 plus 2 times 3. 3 is 6 plus 8, that gives us 8 plus 6, that gives us 14. Then Z is the fourth term. The fourth term. And what is the fourth term of an AP? That will be A plus 3D. So Z is equal to A plus 3D, which is the fourth term. We know the A, we know D, we can substitute that here. So that give us A plus 9, that give us 17. So technically our X is 11, Y is 14, and Z is 17. So that's the solution to that question. Still on arithmetic progression. So we have been solving arithmetic progression so far. Different question, different ways that a question can come our way, either by finding the terms, or by finding some indirect question, the number of terms in a sequence given the last term, or we can be given some question using the idea of common difference to solve those questions, like we have said just solved now. There are other ways in which you can also be tested on arithmetic progression. There are some questions in arithmetic progression that will lead to simultaneous equation. I think I've already referenced that before, and those are the where the exam questions usually come from, where WAEC or examination question usually come from. There are some questions given to the SS1 student in further mathematics second term examination in Lagos State that are related to this simultaneous equation in AP and GP. So I want you to pay attention to that, to how do we solve questions that will lead to simultaneous equation in arithmetic progression. Let's look at this first question. The fourth term of an arithmetic progression is 15. How can we interpret that? The fourth term of an arithmetic progression is 15. How can you interpret that? What is the fourth term of an arithmetic progression? I leave you with that question to answer. What is the fourth term of an arithmetic progression? That is A plus 3D. Am I correct? A plus 3D is the fourth term of an arithmetic progression. So, and we have been given the value of it, which is what, 15. So that means we have A plus 3D equals to what, 15. We can call that one equation 1. And the ninth term is 35. The question is, what is the ninth term of an arithmetic progression? I ask you a question again. So the ninth term is A plus 8D. A plus 8D. So we have A plus 8D equals to 35. So we have to find the 15th term. So we cannot find 15th term unless we know the first term and we know the common difference of the arithmetic progression. And that's what we can find from these two equations here. We can get our A, we can get our D, so that we can find the 15th term of the arithmetic progression. So now the fourth term is 15. Then we have A plus 3D equals 15. And the ninth term is 35. Then we have A plus 8D equals to 35. So we can solve these two equations simultaneously by using any method we know, whether elimination method or substitution method, because these are linear equations. So, but you can use the elimination here, because you can see that the equation of A here are already equal. So we can just subtract so that we can eliminate A here. So I said subtract equation 1 from equation 2. So remove this equation from this equation. So then we have A minus A, that will give us 0. 8D minus 3D, that will give us 5D. 35 minus 15, that gives us a 20. So now you have eliminated A, you can find D there by dividing both sides by 5. So that means D will be equal to 4. So that means the common difference for this arithmetic progression is what? 4. Now that we know the common difference, we can find the first term, our A, by substituting this value into any of these equations, whether equation 1 or equation 2. So put D equals to 4 into equation 1. That means you have equation 1 to be A plus 3D equals to 15. We have A plus 3 times 4 equals to 15. 3 times 4 is 12. So we have A plus 12 equals to 15. So collect like time, you have A equals to 15 minus 12. That gives us 3. So that means the first term of this arithmetic progression is what? 3. So let me just test your ability. Now that we know the first term, A3, and we know the common difference to be 4, can you tell me the second term of the first term is 3? Can you tell me the second term of the AP? That will be A plus D. So that will give us 3 plus 4. That will give us 7. The first time is 3. The second time, the next time is 4. The next one will be what? If you add 4 to 7, that will give us 11, and so on like that. But in this case, they ask us to find the 15th term of the arithmetic progression. 15th term. If I ask you what is the 15th term of an AP, 15th term of an AP, that should be A plus 14D. So the 15th term of an AP is A plus 14D. So we know now our A, we know our D now, so we can find that. So A is 3 plus 14 times 4. 14 times 4 is 56 plus 3, that gives us 59. So that means the 15th term of that sequence is 59. Is it difficult? I ask you a question. No, I don't think so. So these are the questions in AP that leads to simultaneous equation. Let's see another one quickly. Look at this question. In an AP arithmetic progression, the 10 terms is 68, while its fourth term is 26. Find the common difference and the first term. I believe you should be able to do this one as well. It's very simple. You ask yourself, what is the 10th term of an AP? 10th term of an AP is what? A plus 9D. And we are told that it is equal to 68. You will call it equation 1. The fourth term of that same AP, that is A plus 3D equals to 26. Equation 2. So you can solve this equation, these two equations simultaneously to find our A and our D. So we have to find common difference, which is our D, and we have to find the first one, which is our A. So like we did earlier, we can just subtract this equation 1 from equation 2, or equation 2 from equation 1, anyone you think, or anyone you can do best. So in this case, we subtract equation 2 from equation 1. So subtract equation 2 from equation 1. That means we have a minus a, that gives us 0. 9d minus 3d, that gives us 6d. Then 68 minus 26 gives us 42. So from there, we can divide both sides by 6 to get the value of our d. So d will be equal to 7. That's the common difference. That's our a. Then you can substitute the value of d into any of equation 1 or equation 2 to find the value of our a. So put d equals to 7 into equation 2. What is equation 2? A plus 3d equals to 26. So we have a plus 3 times 7 equals 26. 3 times 7 is 21. That a plus 21 equals 26. Then collect like times there. They have a equals to 26 minus 21. That gives us a to be 5, which is the first term. So in this question, we are not to do any other thing. You are only to know the common difference and the first term. So, which I believe is very simple as well. Do you understand that? If you do, let's continue. Let's see this Y question. Y 215 question number 9a. Y 215 question number 9a. Let's look at it. The first term of an AP is minus 8. That means, how can you interpret that? What's the first term of an AP? A. That means A is equal to what? Minus 8. If the ratio of the 7th term to 9th term is 5 to 8. Interesting question. Interesting question. Now, yeah, they are bringing ratio into arithmetic progression now. It's very simple. Don't be scared. Very, very simple. So the ratio of the 7th term. What is the 7th term of an AP? 7th term of an AP is what? A plus 6D. A plus 6D. The ratio of it to 9th term. What is 9th term of an AP? A plus 8D is equal to 5 to 8. That's the interpretation to that question. The ratio of 7th term to 9th term is equal to 5 to 8. Then from the idea of the ratio, we know that this one means division. So this to this means this divided by this. So that means A plus 6D over A plus 8D equals to 5 divided by 8. Then from there you can collect like times. Also you can cross multiply rather. 8 will multiply this, then 5 will multiply this. So which is 8 into A plus 6D equals to 5 into A plus 8D. If you open the brackets, we have 8A plus 48D equals to 5A plus 40D. You can collect like times from both from there. What do we have? We have that 5A will go here. That means you have 8A minus 5A equals to 40D minus 48D. 8A minus 5A will give us 3A equals to 40D minus 48D will give us minus 8D. We have been given the value of our first term, which is our minus 8. If you put that there, you have 3 times minus 8 equals to minus 8D. So because I have to find the common difference, which is our D. So 3 times minus 8 is minus 24. equals to minus 8d. You can divide both sides by minus 8. So that will minus will take care of minus. So 24 divided by 8 will give us a 3. So that means the common difference is 3. The common difference is what? Is 3. So you can see that that question is very simple as well. It's just a matter of interpreting the question. Alright, if you understand what you have been doing so far on the arithmetic progression, so far you can attempt, you do this assignment from question number 1 to question number 5. Number 1 say that the 12th term of an AP is minus 41. If the first term is 3, find the 28th term. So if you know the first term, then you need to get the common difference from this. Then you can find the 28th term. This as well is similar to what you have solved before. The fourth term of an AP is this, and the sixth term is this. Then the sixth term is 12 more than the fourth term. Interesting. That's the word problem. The fourth term is this, and the sixth term is 12 more than this. So that means if you remove the fourth term from the sixth term, the answer should be what? 12. If you remove the fourth, because sixth term is 4 times more, sixth term is 12 more than this. If I ask you, if I say that Bola is the age of Bola is Bola is older than our sister by 12 years old. So that means the age of the brother, if you add 12 to it, will be equal to the age of Bola as well. So the same thing here. If 12 is sixth term is 12 more than fourth term, so that means if I remove the fourth term from the sixth term, the answer should be 12. If the age of a boy from the Bola is 12 years more than his brother, that means if I remove the age of brother from the Bola, that means you give me 12. That's what it means as well. So you can use that to solve this question, and so on like that. So attempt this question, and let's see what you get. Now we are going to be talking about the sum of term of arithmetic progression. How do we sum terms together in AP? We know that in AP we have what is called term, which is talking about the position of all the numbers in the sequence. We are summing the terms together. We are summing the first term, third term, the second term, third term, fourth term, fifth term to the end term. We are summing it together. Then how do we do that? An example is that there was a particular year. It's a story that in a particular school, some students were making noise in a class, and the teacher was passing by, and the teacher decided to punish those students. He now entered the student class and asked the student to bring out their book, and they bring out their biro, and they start adding 1 to 100 together. They are to add 1 to 100 together. 1 plus 2 plus 3 plus 4 plus 5, keep adding it to 100 in order to punish them or keep them busy. So as the teacher was about to leave the class, and a student just said the answer immediately. The answer is 50-50, 5050. The teacher was surprised that how was the student able to get the answer within few seconds or a minute. What has the student used? The student has used the sum of the term of an arithmetic progression. The student use the sum of the term of an arithmetic progression, because 1 to 100 is same thing as it's an arithmetic progression. 1, 2, 3, because the first term is 1 and it has common difference, which is also what? 1. So, and the number of terms in 1 to 100 is 100. So it sum the 1 to 100 together within few seconds using the sum of term of an arithmetic progression. So why did I give you that story? This is talking about we can sum any number of terms together. I can sum the first 20 together. I can sum the first 10 together. I can sum the first 5 of an arithmetic progression together. Any number of terms in arithmetic progression can be summed together using this formula and this formula. Are we there? So we have sum of term of an AP equals to n over 2 into 2a plus n minus 1 close the bracket, close the bracket, multiply by d, close the bracket. This bracket at the back here is for this 1 year, and this one is closed here. So you should be able to please know when to put the brackets. So this formula is used to find the sum of terms. So sum of number of terms you are looking for. If I'm summing 10, that will be sum of 10. Your n here is the term you are summing together. How many times are you summing together? Is it 10? Is it 5? Is it 20? So n is number of times, number of times you are summing together. You know that your a is first term, and your n is the number of times you are summing together, and your d is the common difference. So that's the statement you have here. So we can also use this formula as well to sum terms together. You can use it as well. Now we see how sum of term equals to n over 2 into a plus the last term. L means the last term. And if you remember that we said that the last term or the n term is the same thing as a plus open bracket n minus 1 or close bracket d. So this formula and this formula, they are the same thing, because if I put the last term here, which is a plus n minus 1 into bracket d, a plus a will give me 2a plus n minus 1d. So this formula and this formula are still the same thing, but they serve the same different purpose. There's a situation whereby you can use this, there's a situation whereby you can use this one. For instance, if I'm giving a question to sum terms together and I'm giving the number of terms, I know the number of terms, I know the first term, and I know the common difference, I can use this one. But there's a situation whereby I don't know the common difference, and I know the last term of that sequence. I can use the first term and the last term and the number of terms in that sequence to sum this term together. So if I know the last term, I don't need to use this one. I can just use this one to sum this term together. But if I don't know the last term of the sequence, then I need to use this to sum terms together. So there's a way we can use this, there's a way you can use this one as well, but they both mean the same thing, literally. Do we understand that? So let's see how we can use this quickly. Now let's see this. Find the sum of 1, 2, 3, 4, 5 to 100. This is the story I told you right now. This is the story that I said before. We are summing these terms, these 1 to 100s together. We are summing 1 to 100 together. And in this case, you can see that we are not told that whether it belongs to AP or GP, but we know that it belongs to AP because there is a common difference between all these numbers. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1. So there's a common difference which is 1. That means it belongs to what? AP. So we want to sum them, but how many times do we have between 1 to 100? What's the value of our n? N is what? 100, because between 1 to 100 there's 100 times. So therefore our a first term is 1, common difference is also 1. Our n is what? 100. So sum of term is equal to n over 2 into 2a plus n minus 1d. So we are summing sum of 100 together. That means equals to n is 100 over 2 into 2 times 1. Our a is 1 plus 100 minus 1 times common difference, which is 1. So that means 100 divided by 2 give us 50 into 2 times 1 is 2. 100 minus 1 is 99 times 1 give us plus 99. So 2 plus 99 give us a 101. 101 times 50 will give us a 5050. So that means this question is being asked in they ask it in quiz, in competition, sum 1 to 100 together. The answer is what? 5050. So literally I can ask you to sum 1 to 1000 together. You shouldn't be scared. 1 to 1000 is also arithmetic progression. So the first term is a, the first term is 1. The common difference is also 1. How many times do we have between 1 to 1000? That is what? 1000. So you can put that in this formula and you get the answer. You can sum it between few seconds. Do we understand that? So I can also use this second formula to sum this, to solve this question, because I know the last term. The last term here is what? 100. Do you understand that? So I will have n over 2 into a, which is the 1, plus the last term. What's the last term? 100. So 1 plus 100 is the what? 101. You can see. Then n, which is 100 over 2, will give us 50. 50 times 101 will give us 50. 50. We still give us the same answer because we know the last term of this sequence. So if you don't know the last term, you cannot use that second formula. Do we understand that? Good. Let's see another question on sum of term in AP. Find the sum of the first 12 terms of the arithmetic progression 2, 5, 8, 11, and so on. So in this case, you can see that in this progression, we don't know the last term. So that means you cannot use the last formula. You are going to use the first one. What are we giving? We know that this arithmetic progression. What's the first term? 2. What's the common difference? The common difference is 3. 5 minus 2 give us 3. And we know the number of times we are summing together. We said we have to sum the first 12 terms. So that means our n is 12. So if you remember the formula of summing terms together, we have sum of time equals to n over 2 into 2a plus into n minus 1 into d, close the bracket. Our n is what? 12. Sum of 12 equals to 12 over 2 into 2 times 2, where our a is 2, plus 12 minus 1 multiplied by common difference, which is 3. So 12 divided by 2 give us 6. 4 times 2 give us 2 times 2 give us 4. 12 minus 1 is 11 times 3, that gives us 33. 33 plus 4 give us 37 times 6 will give us 122. So that means when you continue this sequence to the 12th term and you add all the numbers together, you're going to get 222 as your answer. Do we understand that interpretation? When you continue this sequence 2, 5, 8, 11, and you continue to list the sequence to the 12th term, when you now add all these numbers together, sum it together, then you are going to get 222 as your answer. Do we understand that? So let's see another question. The sum of the fourth and the sixth term of an arithmetic progression is 42. Interesting question. The sum of the fourth and sixth terms of an arithmetic progression is 42. It's very simple. You are summing fourth term and sixth term together, and the answer is 42. The question is, what is the fourth term of an AP? What is the fourth term of an AP? A plus 3D. Plus, what is the sixth term of an AP? A plus 5D equals to 42. So we are summing sixth term and fourth term and sixth term together. This is the fourth term and this is the sixth term. And the answer gives us 42. So you can simplify that further. A plus A give us 2A. 3D plus 5D give us 8D equals to 42. So, but something is common to this. 2 is common. You can divide through by 2. Divide this one by 2 give us A. Divide this one by 2 give us 4D. Divide this one by 2 give us 21D. We can call that one equation 1. Do we understand that? Let's continue. The sum of the third and the ninth terms of the progression is 52. Interesting. The same way you interpret this, you can also interpret this one as well. What is the third term of an AP? A plus 2D. Plus, what is the ninth term of an AP? A plus 8D is equal to 52. Collect like times A plus A give us 2A. 2 plus AD, so 2D plus AD give us 10D equals to 52. 2 is also common. You can divide through by 2. That gives us A plus 5D equals to 26. You can call that equation 2 as well. So, question asks us to find the first term, the common difference, and the sum of the first 10 terms of the progression. So, from these two equations we have gotten here, we can find the first term, we can find the common difference. So you can solve these two equations simultaneously, whether by elimination or substitution. But I know it can be solved using elimination easily, because this question of A here and question of A here are also already equal. So what do? We can remove equation 1 from equation 2, subtract equation 1 from equation 2. So that means you have A minus A, that gives us 0. 5D minus 4D, that gives us D. 26 minus 21 gives us 5. So that means the common difference is 5. Then you can put this one into equation 1 or equation 2 to get our A. So we put that into equation 1. A plus 4 times D is 5 times 5 equals to 21. That means you have A plus 20 equals to 21. A equals to 21 minus 20. By collecting like times, A will be 1. So that means the common difference is 5. The first term is 1. Then from there, now that we know the first term, we know the common difference, we can find the sum of the first 10 terms of the progression. Sum of the first 10 terms. So this formula will find the sum of term in AP, and we are summing 10 terms together. So sum of 10 equals to n is 10 over 2 into 2 times our A is 1 plus open bracket 10 minus 1 into D is 5. So 10 divided by 2 will give us 5 into 2 times 1 is 2 plus 10 minus 1 is 9 times 5, that gives us 45. 45 plus 2 is 47 times 5. That gives us 235. So the sum of the 10th term of the progression is 235. So you can see the question and you can see how cheap the solution is. Do we understand that? All right. So if you understand the sum of term of arithmetic progression as well, then you can attempt this assignment as well. We have to find the sum of the first 11 terms of the sequence, determine the sum of the term of determine the sum of the series, all the series. But you can see that in this series, we don't know the number of times we are summing together. Or do we know it? In this case, we know that we are summing 11 times together, but in this one, determine the sum of the series. So we don't know the number of times we are summing. We are told that this 6.5, 8.0, 9.5, 11.0, that to 32. But we know the last term, which is 32. So we can use that to find the n, the number of n, or the number of terms we have in this sequence. So when we now know our n, we can now sum the terms together. Do you understand that? Here you have to find the 17th term. You have to find the 17th term of this sequence. You are not summing, you are only finding 17th term. Here you have to find the 15th term of the arithmetic progression, which the first term is this and the 10th term is 16. So attempt this question and see what you are going to get. Now we have just ended the first part of the progression we are to discuss in this video. We have extensively talked about arithmetic progression as one of our focus in this video. Now, before we continue the second part of the sequence, which is the geometrical progression, please, if you have not subscribed to this channel, please click the subscribe button right now, so that you will be notified whenever we post information on this platform. You may as well help to improve this channel by sharing the video, like and comment on the video, and as you do so, may the good Lord bless you as you do so. So like I said, the second part of the progression is what we want to discuss now, which is the geometric progression. So like I said, under arithmetic progression, how can I identify a progression that is geometric? How can I identify a sequence that belongs to arithmetic progression? And we know that when it comes to arithmetic progression, we know that the sequence is meant to have common difference. But what about geometric progression? How do we identify a sequence that belongs to geometric progression or exponential sequence? Now, geometric or exponential sequence is a sequence with constant ratio between two successive terms. Underline constant ratio, underline successive terms. So when I have a sequence and I pick two successive terms and I find the ratio of it and is equal to the ratio of the another two successive terms, then we know that that sequence belongs to geometric progression. You know that meaning of ratio means that you divide. Like you know that okay, let's say example, we have 2, 4, 8, 16, 32, 64 here. I want to ask you a question. Does this sequence belong to AP, arithmetic progression? No, it does not belong to AP because it does not have a common difference. 4 minus 2 is 2. 8 minus 4, is it 2? It's 4. No, so it's not equal to 2. 16 minus 8, is it 2? No, it's not equal to 2. It's 8. So that means this sequence does not belong to AP. Rather, it belongs to geometric progression because it has constant ratio between two successive terms. How is that possible? Let's see. What do you mean by ratio? Division. Ratio means division. So between two successive terms, 4 divided by 2, that is 2. 8 divided by 4, that is 2. 16 divided by 8, that is 2. 32 divided by 16, that is 2. 64 divided by 2, that is also 2. So we can see that there is a constant ratio between any two successive terms. So that means the sequence belongs to geometric progression. So if truly you want to identify or you want to know how to identify a sequence that belongs to geometric progression, the sequence must have constant ratio between two successive terms. Do you understand that now? Let's look at this one. Does this one belongs to AP? No, because it does not have a common difference. Rather, it belongs to geometric what progression. Let's see. What is 12 divided by 6? That will give us 2. 24 divided by 12 is what? 2. 48 divided by 24 is what? 2. So you can see that there's a constant ratio between two successive terms here. Let's look at this as well. Does it belong to AP? No, it does not have common difference, but it belongs to what? GP, geometric progression. 12 divided by 36, that should give us a 1 over 3. 4 divided by 12, that will give us a 1 over 3 as well. 4 divided by 3 divided by 4, that will give us a 1 over 12 as well. So that means the constant ratio there is what? 4 over 3. Constant ratio here is what? 2. Constant ratio here is also what? 2. So now you should be able to identify sequence that belongs to AP, sequence that belongs to GP, because you should know the definition of AP and GP. GP has constant ratio between two successive terms. AP have common difference between two successive terms. Do you understand that now? Good. Also, the position of the sequence here are also called terms. This is the first, second, third, fourth, fifth, sixth, and to the last term. Just like the same thing in the AP. So we use A to represent the first term also in GP. But the constant ratio, we use R to represent the constant ratio. You know, in common difference in AP, we use D to represent that one. But in the GP, we use R to represent the constant ratio. So A is the first term, R is the constant ratio. Now, let's see the first term of an exponential sequence. Let's see that. How do we identify the terms in geometric progression? We know that in arithmetic progression, the first term is A, second term is A plus D, third term is A plus 2D, fourth term is A plus 3D, and so on. The same thing is we can also do that in GP as well. Let's see. This sequence, does it belong to AP or GP? It belongs to GP because there is a constant ratio. R is a constant ratio which is equal to 4 divided by 2, and that gives us 2, or 8 divided by 4 gives us 2, 16 divided by 8 gives us 2. So that means it belongs to GP. Like I said here, first term of GP is also equals to A. So we use A to represent the first term of GP. Then second term of a GP is AR, or A times R. This second term of an AP is A plus D. But look at the second term of a GP is what? AR, A times R. First time times the constant ratio. What about third term of a GP? Third term of a GP is AR squared. Fourth term of a GP is AR raised to power 3, or AR cube. What will be the fifth term of GP? That will be AR raised to power 4. What is the sixth term of a GP? AR raised to power 5. What is seventh term of a GP? AR raised to power 6. If I ask you what is the seventh term of a GP, okay, it's already AR raised to power 6. 10th term of a GP, 10. The 10th term of a GP is what? AR raised to power 9. The 20th term of a GP, AR raised to power 19. 58th term of a GP is AR raised to power 49. Do you understand that now? Then how did they get that? Okay. The way they got the first term is A multiplied by R raised to power the number of times you're looking for, which is 1, or first 1 minus 1. That will give us R raised to power 0. R raised to power 0 is what? 1. Then 1 times A will give us A. In this case, our second term is our N is 2. R raised to power 2 minus 1. That gives us 1. Then R raised to power 1 is same as R. That means we have A raised to AR.
For the third term, our n is 3. A raised to power 3 minus 1. That give us these two. Fourth term, A raised to power 4 minus 1. That gives us 3. The seventh term of the GP is AR raised to power 7 minus 1. That gives us AR raised to power 6. So I can ask you, what is the sixth term of a GP? You should be able to tell me AR raised to power 5, or you can play with this thing. What is a 30th term of a GP? It is AR raised to power 29. What is the 17th term of a GP? It is AR raised to power 16. What is a 100th term of a GP? It is AR raised to power 99. So the same pattern with the that of AP. AP is you're having plus A plus something, A plus something, A plus something. But in GP, A are raised to power something depending on the term you are looking for. And don't forget that the power only affects the R, not A and not A. It's not only the power is not affecting A, it's only affecting R, the constant ratio. So therefore, having known that so that means if you want to find any term of a GP, we can use the formula AR raised to power n minus 1, where your n is the term you are looking for. Like 20 times, that would be 20 minus 1, that will give us a AR raised to power 19. Like 30 times, that would be 30th time, that would be 30 minus 1, that will give us AR raised to power 29. So we can find the any term of a GP using this formula. Do we understand that? Alright, if you understand that, let's solve this first question on GP. Find the seventh term of the geometric progression 4, 12, 36, and so on. This progression, does it belong to geometric progression or AP? It does not belong to AP because it does not have a common difference. Rather, it belongs to geometric progression. So we have to find the seventh term. What does that mean? That if we continue the terms, by the time we get to seventh term, what are we going to see there? That's what we have to find. This one is the first, second, third. So we don't know the next one. By the time we get to seventh, what do we get there? That's what they want you to find. Then how do we do that? We can use the formula of finding number of term in GP, which is AR raised to power n minus 1. But in this case, you have to find the seventh term. That means you'll be having AR raised to power 7 minus 1. So that means the seventh term of a GP is AR raised to power 6. Do you understand that? So our A is the first term, 4, and we can get the constant ratio, our R, by dividing the second term by first, or by dividing the third by second. So that means you have 12 divided by 4, that gives us 3. So that means the constant ratio is 3. So therefore, the number of terms is AR raised to power n minus 1, and we are looking for the seventh term. That will be A raised to power, so AR raised to power 6 is equals to, our A is 4 times constant ratio is 3 raised to power 6. 3 raised to power 6 is 729 times 4. That gives us a 2916. So when you continue this sequence to the 7 times, we are going to get 2916 there as the seventh term. Do we understand that? Next question. Find the 12th term of the GP. Minus 3, 16, minus 12, and so on. So 12th term, in this case, our n is what? 12. Our n is what? 12. And what is the 12th term of a GP? That you can get by putting in the formula for finding number of term, or you can just tell us the 12th term of a GP straight away. What is the 12th term of a GP? That is AR raised to power 11. AR raised to power 11 is the 12th term of a GP. So our A is, what's our first term? Minus 3. And our constant ratio will be this divided by this. That will give us 6 divided by minus 3. That will give us minus 2. So we are looking for the 12th term, which is AR raised to power 12 minus 1, which is AR raised to power 11, is equals to A is minus 3 times our R is minus 2. Put that in bracket so that it will not affect it, so that it will not contradict these times. Then raised to power 11. Then minus 2 raised to power 11 will give us a minus 2048. Then minus times minus will give us plus. 3 times 2040 will give us 6144. So when you continue this sequence, this GP, and you get to the 12 terms, we are going to see 6,144 there. Do we understand that? Next question. Let's look at this question on sort that belongs to sequence. Let's look at it. Given that sort 6, 3 sort 2, 3 sort 6, 9 sort 2, dot are the first 4 terms of an exponential sequence. First 4 terms. That means this is the first, second, third, and fourth. Find its simplest form. So find in its simplest form the 8th term. So we want to find the 8th term of this sequence. Now, since you have been told that this sequence belongs to exponential sequence, so that means it must have a constant ratio. Now, what is the first term of this sequence? It is sort 6. Then you have to get the constant ratio. That means you have a 3 sort 2 divided by sort 6. 3 sort 2 divided by sort 6. And you should know from your idea of sort, you cannot leave your answer like this, that the denominator is in sort form. So that means we need to rationalize. That means sort 6 will multiply up and down, and that's what we are having here. Then sort 6 times sort 6 will give us 6. Then 6 sort 6 times 3 sort 6 times sort 6. Excuse me. Sort 6 times sort 2 will give us sort 12. So that means you have 3 sort 12 here. But we know that you can simplify sort 12 further, because it is not yet simplified to the simplest form. If you simplify sort 12, what would that give you? That gives us 2 sort 3, because sort 12 is 4 times 3. So sort 4 is 2. 3 times 2 here will give us 6. Then you are left with sort 3. So then we have sort 6 sort 3 over 6. Then 6 can take care of 6. Then we are left with sort 3. So that means the constant ratio is the sort 3. So the constant ratio is what? Sort 3. So the question asks us to find the 8th term of this sequence. What is the 8th term of a GP? What's the 8th term of a GP? I want to ask you that question. I want you to answer me. The 8th term of GP is AR raised to power 7. AR raised to power 7. AR raised to power 7. That you can get from the formula of finding number of term of a GP. So you have AR raised to power 8 minus 7, because you are looking for 8th term. So n is 8. 8 minus 7 give us 8 minus 1 give us 7. So the 8th term is AR raised to power 7 is equals to, our A is sort 6 times our R is sort 3. So sort 3 raised to power 7 is equals to, we know that this sort 3 raised to power 7 means that sort 3 in 7 places. So that means you have sort 6 times sort 3 in 7 places. 1, 2, 3, 4, 5, 6, 7. So from there we can now go ahead and simplify further. Are we ready? What is sort 3 times sort 3? That should give us 3. Sort 3 times sort 3 give us another 3. Sort 3 times sort 3 give us another 3. So you have 3 times 3 times 3, that gives us 27. 27 times sort 3 give us 27 sort 3. So what you're having here, then times this sort 6 here. Then from there, sort 3 times sort 6 will give us sort 18. So that means you have 27 sort 18 left. But we can simplify sort 18 further, because sort 18 will give us 9 times 2. So we can simplify sort 19. So sort 9 rather. Sort 9 is 3. So 3 times 27 will give us 81. Then sort 2. So the 8th term of this sequence is 81 sort 2. I hope you understand that very well. Good. Let's look at this question now. Find the number of terms in the sequence 2, 4, 8, 16, 32. That's to 2048. Please, I want you to understand this question now. We are not looking for a particular term now. We are looking for how many terms do we have from between 2 and 2048. So we are looking for the value of our n in this case, just like in that of the question we solved under arithmetic progression. So we know the last term, which is 2048. Then we know the first term. We can find a constant ratio. Then we can use that to find the value of our n. Do we understand that? So we know the first term is to be 2. The constant ratio is also 2, because 4 divided by 2 will give us 2. So we don't know the value of our n. That we have to find. and we know the nth term. Our nth term is 2048, or the last term. Let's call it the last term or the nth term, 2048. And we know that the same formula of a number of term or nth term of a arithmetic progression is a raised to power n minus 1. So that means the nth term is 2048 equals to a is 2, r is also 2 raised to power n minus 1, because we are looking for the value of our n here. So what can we do? We can divide both sides by these 2 here. These 2 here, you can divide both sides by 2. Then that will give us a 1024 equals to 2 raised to power n minus 1. Then you can change this 1024 into an index form that will have the base of 2. That will be 2 raised to power 10. Then 2 can take care of 2 here. The base can take care of the base. Then we have 10 is equals to n minus 1 left. 10 is equals to n minus 1. So from there, we can find the value of our n by collecting like time. So n will be 10 plus 1. That will give us 11. So n is 11. That means we have 11 terms between 2 and 2048. We have 11 terms in between them. Do we understand that? Good. Let's look at this question as well. The system of a GP is 1215. The system of a GP is 1215. If I should ask you, what is the system of a GP? What is the system of a GP? Let me pause for a while and you say the answer and write it down, or you answer yourself. The system of a GP is what? That is AR raised to power 5. AR raised to power 5 is system of a GP. So that's what you're having here. AR raised to power 5 is equals to 1215. If the constant ratio is 3, that means our R is what? 3. The constant ratio is 3. So that means you have a times r raised to power 5 equals to 1215. 3 raised to power 5 same thing as 243. Then times a will give us 243 equals to this. So we can divide both sides by 243. Then our a will be equals to 5. So that means the constant ratio is 3. The first term is what? 5. The question asks us to find the third term. The third term. What is the third term of a GP? What is the third term of a GP? The third term of a GP is AR squared. AR squared. So which is equal to our a is 5 times 3 raised to power 2, because the constant ratio is 3. 3 raised to power 2 is 9 times 5. That gives us 45. So that means the third term of the GP is 45. Do we understand? Now also in GP as well, there are some questions that will lead to simultaneous equation, just like we did under arithmetic progression. In GP, there are some questions that lead to simultaneous equation, just like we saw under arithmetic progression as well. So I want you to understand this as well. Let's see that the second term of an exponential sequence is 35. How do we write the second term of a GP? Second term of a GP is what? AR. Then it's equals to what? 35. You can call that one equation 1. And the fourth term is 875. 875. So what is the fourth term of a GP? AR raised to power 3 equals to 875. You can call down equation 2. So we can now solve equation 1 and equation 2 simultaneously now. So we can solve equation 1 and equation 2 simultaneously. So in this case, we cannot add or subtract, because we are not having addition or subtraction between the terms here. No, we are having multiplication here. So what are we going to do? We are going to divide one of the equation by the second one. So in this case, you divide equation 2 by equation 1. Equation 2, that means equation 2 divided by equation 1. So that means you have AR cubed divided by AR equals to 875 divided by what? 35. Divide this side by this, then this by this. So a will cancel a. R we go in r cubed. Then we are left with r squared. Then 35 in 875 give us 25. So then we are left with r squared equals 25. So you can find the square root of both sides. R will be equal to 5. So that means the constant ratio is what? 5. Then we can now put that into any of these equations to find the value of our A. Put R equals to 5 into equation 1. Equation 1 is AR equals to 35. So if you put your R here, that means you have a 5A equals to 35. Divide both sides by 5, that means A will be 7. So now we know the constant ratio 5. We know the first term 7. We can find, okay, we have to find the first term and the fifth term. So we know the first term to be 7. So we cannot find the fifth term if we don't know the constant ratio, which we have already also gotten. So we can also to find the fifth term, which you can find using the formula of finding number of terms, which is a raised to power n minus 1. But our n in this case is what? 5. So the fifth term will be a raised to power what? 4. So a raised to power 4 equals to our a is 7 times our r is 5 raised to power 4. 5 raised to power 4 is 625. Then times 7 will give us 4,375. You can see that the question is very simple. Let's see another one. Find the two possible values of p if p minus 3, 3p plus 5 and 18p minus 5 are 3 consecutive terms of a geometrical progression. You have seen this kind of question under arithmetic progression that we are asked to find the value of, I think, x, and we use the idea of a common difference to find it. But here, what are we going to use to find it here? We are going to use the idea of a constant ratio. Since this progression are consecutive terms, you can say this is the first, second, third, because they are consecutive. So that means the ratio of this with this should be equal to the ratio of this with this as well, because they must have constant ratio between two successive terms. That's what make it a geometrical progression. So the second divided by the first, 3p plus 5 over p minus 3 should be equal to this by this as well, 18p minus 5 over 3p plus 5, because they should have constant ratio. From there, we can use that to find our p by cross multiplying. In cross multiply, you have 3p in bracket, in another bracket 3p plus 5 as well, equals to this multiplied by this, all you have in the bracket. Then you can now open the bracket. 3p times 3p will give us 9p square. 3p times 5 will give us 15p. 5 times 3p will give us 15p. 5 times 5 will give us 25, equals to p times 18p will give us 18p squared. P times minus 5 will give us minus 5p. Minus 3 times 18p will give us minus 54p. Minus 3 times minus 5 will give us plus 15. From there, 15p plus 15p will give us 30p here. Also minus 55p minus 54p will give us minus 59p. From there, you can collect like times. We can bring this everything here to the other side here. Everything at the left hand side to the right hand side. We have a 18p square minus 9p square. That will give us a 9p square. Here you're having minus 59p minus 30p. That will give us a minus 89p. Then 15 minus 25, that will give us minus 10, is equals to 0. Then we can now solve this quadratic equation now using any method we know. But this can be solved using some factorization method. 9 will multiply minus 10, that will give us minus 90. Look for two numbers you can multiply together to give us minus 90. And when you add them together, it will give us a minus 89 here. So that should give us a minus 90 plus 1. Minus 90 plus 1. Minus 90 times 1 will give us a minus 90. Then minus 90 plus 1 will give us minus 89. So that means you'll be having 9p squared minus 90p plus p, which is representing 1, here, minus 10 is equals to 0. Factorize. 9p is common. You have 9p into p minus 10. What is common here? Plus 1 is common into p minus 10 equals to 0. You know that the brackets are meant to be equal. Then bring this and this together. You have 9p plus 1 into p minus 10 equals to 0. Then from there you can solve for the value of your p. 9p plus 1 equals to 0. Then collect like and p will be equals to minus 1 over 9. P minus 10 is also equal to 0. Then p will be equals to 10. So from there, the value of our p is either minus 1 over 9, or p is equals to 10. So like WAEC last year, they gave them this kind of question like in WAEC 2022. they gave them something, a question like this, but there is a condition for your R. They said the R is greater than 1. So when they solve the question, they get the same answer like this, two answers like this, but one of them is a negative number. So they expect you to now specify which one is your answer out of the two, because since your R is greater than -1, so when you put your P here, you get the constant ratio. So P got 30 plus 5, that'll give us 35 over 7. 35 divided by 7, that give us 5. So 35 divided by 7 give us 5. So that means constant ratio is 5. Because if you put minus here, you will be getting minus as your answer. So your answer cannot be negative value, because if your R is greater than 1, so your answer is going to be positive value. So that's the condition they gave them last year. But this question is very simple, is similar to WAEC 2022. Now let's look at this question as well. The third term of a geometric progression is 24. What is the third term of a GP? If I may ask you, the third term of a GP is AR what? AR squared. So the third term of a GP is AR squared, and that means you have AR squared equals 24. You can call that equation 1. And the seventh term is 4 number 20 over 27. What is the seventh term of a GP? That is AR raised to power C equals to 4 number 20 over 27, which if you change to improper fraction, you have 128 over 27. You can call that equation 2. So you have to find its first term. So this is a WAEC 2010 question number 13A there. WAEC 2010 question number 13A. So now you can solve this equation simultaneously by dividing equation 2 by equation 1. Or anyone you want to do, whether you want to divide equation 2 by equation 1, is your choice. So divide equation 2 by equation 1, that means you have A raised to power 6 divided by A raised to power 2. So A will cancel A. R square will go in R raised to power 6, that means you are left with R raised to power 4. Then you'll be having 120 over 27 divided by 24 as well. Do you understand what you wrote here? Then that means you can change this one to times. 128 divided by 27 times 1 over 24. Then if you cut that, you'll be having 16 over 81. Then to get our R, we can find the fourth root of both sides. Our aim is to find R here. We're having R raised to power 4. How can we remove this 4? I can find the fourth root of this. Fourth root of both sides, you'll be having R equals to fourth root of 16 over 81. What's the fourth root of 16? That will be 2. What's the fourth root of 81? That will be 3. So that means the constant ratio is what? 2 over 3. Do you understand that? If you do, now that we know the constant ratio R, we can find our A in any of the equation 1 or equation 2. So put R equals to 2 over 3 into equation 1. So we have AR squared equals to 24. Our R is 2 over 3, so put that here, equals to raised to power 2 equals to 24. So this 2 over 3 raised to power 2 give us a 4 over 9. 4 over 9 times A will give us a 4A over 9 equals 24. Cross multiply. We have 4A equals to 9 times 24 equals to, which is 216. Then to find our A, divide both sides by 4. That means we have A equals to 216 over 4, that gives us 54. That means the first term is what? 54. So that's the WAEC 2010 question number 13A. So if you understand what you have done so far under arithmetic progression, under geometric progression, pardon me for that, then you can attempt this assignment. Determine the 10th term of this sequence or series. Find the 10th term of this series. The first term of a geometric progression is 4, and the 6th term is 128. Determine the 8th and the 11th term. If this and this are the consecutive term of a geometric progression, find the value of y, hence the GP. Then 42, you have to find 42 terms of the GP, leaving your answer in index form. Number 5, the second and the fourth term of a GP is on 10 and 40 respectively. Find the constant ratio, the first term and 8th term of the series. Alright, so also in GP we can sum terms together in GP, just like we did in under arithmetic progression, we can sum terms together in GP. We can sum the first, second, third, fourth to the last term. We can sum them together in GP depending on the number of times you have to sum together. So, but when it comes to summing terms together in GP, we have three formula for summing terms together. So we can sum formula together. We can sum terms together in GP when constant ratio is greater than 1. Then when your constant ratio is 2, 3, 4, 5, and so on, we use this formula to sum terms together. When constant ratio is less than 1, when you are having 0.9, 0.8 or fraction, then we can use this formula to sum terms together, and we can sum to infinity. We can also sum to infinity, because when we say sum to this sequence to infinity, that means use this third formula. Do we understand that? And let's examine the formula. Sum of term equals to A, which is the first term, into the constant ratio raised to power n, where n is the number of times you are summing together, minus 1. Please, this minus 1 is not for the power of n here. This is r raised to power n, then minus 1. This minus 1 does not belong to the power of, you are not having n minus 1 here. It is no. It is r raised to power n, then minus 1 over r minus 1. Are we there? Also here you are having a into 1 minus r raised to power n over 1 minus r. Please, I want you to take note of what you are having here. When r greater than 1, then you are having r come first before minus 1. When it's less than 1, minus 1 come before 1 minus, you are having 1 minus r. Here you are having r minus 1. Take note of that. And whatever you are having here is what you are having down here as well. Whatever you are having here is what you are having down as well. I hope you can differentiate that. And you can see that the r is the one carrying the power of n. So we have to sum to infinity as well. This is infinity, a over 1 minus r. Are we there? So let's see how we can use these three formulas to sum terms in GP. Now the first thing we want to do here is that find the sum of the 9 terms of the series 72.0, 57.6, 46.08, and so on. We have to sum the first 9 terms of the series. We don't know whether the series belongs to AP or it belongs to GP. We don't know whether this series belongs to AP or it belongs to GP, but you can verify yourself. Now, does it belong to AP? No, because AP is meant to have common difference. 59.6 minus 72.0 is supposed to be equal to 46.08 minus this, but they are not equal. So does it have constant ratio? Yes. This divided by this is equal to this divided by this. Let's verify that. R is equal to 57.6 divided by 72.0, which is D divided by this. Is it the same thing as 46.08 divided by 57.6? So, and the answer is what, 0.8. That means there's a constant what ratio. That means this sequence belongs to what, GP, not AP. And the first term is what, 72.0. Do we understand that? Good. So in this case, is our constant ratio greater than 0 or less than 0? Sorry, is it greater than 1 or less than 1? It is less than 1. You are having 0.8 here. So out of these two formula, which one are you going to use? You are going to use this second formula, not this one. So you are going to use this second formula. You will have because our r is less than 1, we have sum of term equals to a into bracket 1 minus r raised to power n over 1 minus r. So we are summing how many times together? Our n is what? 9. We are summing 9 times together, 9. So is equals to, first time is 72 into 1 minus r is 0.8 raised to power 9 over 1 minus 0.8. So from there, we have 72 into 1 minus 0.8 raised to power 9 is 0.1342 over 1 minus 0.8 is 0.2. Then if you simplify this further, this minus this, whatever you get, multiply by 72. Whatever you get divided by 0.2, it gives us 311.7. So when we sum 9 times together, it gives us 311.7. Do you understand that? Let's see another question. This is a NECO question. It's a NECO question. NECO 112, question number 7b. We have 10 over 3, comma 5 over 3, comma 5 over 6, comma dot dot dot. It's a GP. You have been told that it's a GP. Find the 8th term, then sum the first 10 terms. Very interesting. So you have been told that it is GP. So we are looking for the 8th term. So what is the 8th term of a GP? 8th term is AR raised to power 7. So that means we need the first term, which is our A. First term is what? A 10 over 3. And we need the constant ratio, which is our R, equals to this divided by this. So that means you have 5 over 3 divided by 10 over 3. This we can change to times. 5 over 3 times 3 over 10. 3 can take care of 3. 5 can go in 10. That gives us 1 over 2. So that means the common constant ratio is 1 over 2. So we are looking for, now we have the first term, we have the constant ratio. We can find the 8th term. The 8th term is A raised to power 7. So in this case, we have first term is 10 over 3 times constant ratio is 1 over 2 raised to power 7. That will give us 10 over 3 times 1 raised to power 7 is 1. Then over 2 raised to power 7 is 128. From there, 2 can go here 5. Then 2 can go here 64. 64 times 3 will give us 192. So from there, that's the 8th term of the GP. Then the question asks us to find the sum of the first 10 terms. Sum of the first 10 terms. But we don't know which of the formula we are going to use out of the 3. Which one are we going to use? In this case, is our R greater than 1 or less than 1? I want to ask you the question. Our R is less than 1 because half is 0.5. So that means our R is less than 1. So we are going to use this formula. Sum of time equals to A into 1 minus R raised to power n over 1 minus R. So from there, we substitute. We have sum of 10 equals to our first term is 10 over 3 into 1 minus our R is 1 over 2 raised to power 10 over 1 minus 1 over 2. From there, we can simplify further. 10 over 3 into 1 minus 1 raised to power 10 is 1. 2 raised to power 10 is 1024. Oh, close the bracket, divided by, if you find the LCM of this, you have 1 minus half. If you find the LCM of that, that will give us a half. Then from there, we can change this division to times, and we can also find the LCM here in the brackets. So if you find the LCM of the bracket, you'll be having 1024 minus 1 over 1024, and that will give us a 1023 over 124 times 2 over 1. Then from there, 2 can go in the 2 can go in the 1024. That will give us a 512. Then what else can we do? We have 10 over 3 multiplied by this. Then if you multiply this by this and this by this, and you cut, you'll be having 1705 divided by 256 as the sum of the first 10 terms of the geometric progression. So that's the NECO 212 question number 7b. Alright. Find the sum to infinity of the series 3, 1, 1 over 3. Sum to what? Infinity. Look at the way they said the question. Sum to infinity. That means you are going to use the third formula, which is sum to infinity equals to A over 1 over 3, 1 over R. So A over 1 over R. Our A is the first term and our R is the constant ratio. What's the first term here? It is 3. Then constant ratio is this divided by this, or this divided by this. So that is 1 over 3. If you put that into the formula, we have sum to infinity equals to 3, which is our fourth time over 1 minus 1 over 3. Then if you work on the denominator, you can find the LCM here. That will be 3 minus 1 over 3. That gives us a 2 over 3. So that we have 3 over 2 over 3, which can be written as 3 divided by 2 over 3 like this. This you can change to times 3 times 3 over 2. And that should give us 3 times 3 is 9 over 2. So when you sum this to infinity, it's going to give us a 9 over 2. That you continue summing into the last infinity, it's going to give us a 9 over 2. Let's look at this question again. Find the sum of the find the sum of the first 10 term of the geometric 2, 4, 8, 10, So 16, 32 dot dot dot. In this case, you have to sum the first 10 terms. So the first term is 2 and the constant ratio is what? Is 2 as well. So in this case, constant ratio is what? Is greater than what? 1, because R is equal to 2. So constant ratio is greater than 1. Then you're going to use this the first formula. You are going to use the first formula to sum it together. Sum of time is equal to A into bracket R raised to power n minus 1 over R minus 1, because our R is greater than 1. So we are summing sum of 10 equals to our first term, which is 2, into constant ratio is 2 raised to power 10 minus 1 over 2 minus 1. So in this case, we have 2 into 2 raised to power 10 is 1024 minus 1 over 2 minus 1 is 1. So that means 1024 minus 1 gives us 1023 times 2, and divided by 1, that will give us this back. Then if we multiply by 2, that will give us 2046. That when you sum this, the first 10 times together, when you're going to give us 2046. So let's look at this question. The third term of a geometrical progression is 63. Of course, this is a word problem that will lead to simultaneous equation like as well. The third term of a geometric progression is what? 63. What's the third term of a geometric progression? That's AR raised to power 2. And that's equal to 63, equation 1. And the fifth term is 567. What is the fifth term of a GP? That is the AR raised to power 4 equals to 567, equation 2. Then find the sum of the first system of the progression. We cannot sum the first system together if you don't know the value of our first term and the constant ratio as well. So with this now, you can find the first term and the constant ratio. So by solving this simultaneously, so you can divide equation 2 by equation 1. So then we have AR raised to power 4 divided by AR raised to power 2 equals to 567 divided by 63. A we cancel A. R square we go in R raised to power 4, we are left with R raised to power 2. Then 567 divided by 63, that gives us 9. Then you can take square root of both sides. That means R equals to be 3. So that means the constant ratio is 3. Then you can put this in equation 1 to find our A. So from equation 1, AR square equals to 63. Our R is 3. So that means you have, if you put your 3 here, that means you have 3 squared, that will be 9. Then times A, that gives us 9A equals to 63. You can divide both sides by 9. So that means A will be 7. So that means the first term is 7. The constant ratio is what? 3. Now that we know that, we can sum the first 6 terms together, because we know that we are summing 6 terms. That means our n is 6. So, but out of the 3 formula for summing terms together in GP, which one are we going to use? We are going to use the one when our R is greater than what? 1, because our R is greater than, our R is 3 years, that means greater than 1. And that will be this formula: A into R raised to power n minus 1 over R raised to power R minus 1, because our R is greater than 1. So we are summing 6 terms together. Sum of 6 is equal to, the first term is 7 into constant ratio is 3 raised to power 6 minus 1 over 3 minus 1. So from there you can simplify further. 3 raised to power 6 is 721 minus 1 over 3 minus 1 is 2. From there, what can we do? 729 minus 1 will give us 728. From there, 7 times 728 divided by 2 will give us 2548. So when you sum the system of the progression together, it's going to give us 2548. So if you understand the sum of terms in GP, quite alright. So you can lay your hands on this 4 questions to evaluate you or yourself, so that you will know whether you understand how to sum GP together, and which of the formula you are meant to use at a particular time. So that is that on a GP, and that is that on a sequence and series. But it does not end there. There are real life application to sequence and series. Just like when somebody earn a salary, somebody is starting a job, and is meant to earn a salary of 1,000 naira every month, and at the end of the first month, for the subsequent month, they're going to be adding 200 naira to the salary. So they can ask you to find the how much the person is going to earn in the 6 months, because that one will form arithmetic progression. If the first month he collect 1,000, the second month he will collect 1,200, because 200 has been added. So this third month he will collect 1,400, so and so on like that. So you can know how much the person is going to collect at the end of the 1 year, which is 12 times. You can know how much the person is going to earn at the end of a whole some years. So these are real application of sequence and series. They are very, very applicable in a real life situation. So if you understand what you have been doing so far, and you understand the video is very you can relate with it, and you may give the thumb up to the video by clicking the thumb up in the comment section. You can like the video, comment on it, then share the video with your colleagues in different schools. Give the video a wide publication, and if you have not subscribed, please click on the subscribe button on the channel right now, and you can also click on the notification button so that you'll be notified whenever we post information on this platform. And as you do so, may the good Lord bless you. I will see you in the next video. Bye bye.